Hi, this is our mechanical system. My name is Kyle Mocht. I'm an architectural engineering construction management student in my 5th year at Penn State. In this room, it houses all of our systems for our home. We have these two power converters. They're inverters. They take the power produced by the solar panels and convert it to the power that we can use in our home. This is for the main array, which is that fixed array on our roof. It's bigger, so the size is bigger. We have this guy here, which is for that adjustable array that you learned about. On the other side of the room, we have the control system. It's all computerized controls monitoring basically everything in this home and all the different temperatures, the CO2, everything, all the heat of all the pipes, everything you can imagine to try to control this home the perfect way we can. You have this unit here. This is our main unit. It's a ground source heat pump coupled with an air handling unit. So what we're able to do is do forced air cooling. We could do forced air heating if we wanted to, but we decided not to do that because it's not as efficient as radiant floor heating. We have 1 inch of bluestone on our floor, so we have a high thermal mass. What we're doing is running tubes underneath that with hot water in it to heat the home. The great thing about that is you're able to heat only the occupied space because you're starting from the floor as opposed to blowing air all around your home. That's a lot more efficient. Also, water holds heat much better than air does. So that's the point of that system. Once this gets back to Penn State, we can hook this into the ground like it's intended for. During the competition, we have a unit on the roof that exchanges heat. This guy here it's the same type of unit. It's also a heat pump. However, this is exchanging heat from our home. All of the heat that we're using, all the excess heat that normally you throw outside of your house, we're trying to throw into this room. So we're trying to turn this room into a sauna. But then by doing that, we're taking all that heat that was thrown into this room and putting it back into our water supply. So this whole room turns into a fridge then. So all of our heat is put back into our water system. If it gets overheated, we release the heat through the roof. This guy, when it's cooling, instead of taking the air out of the house and just blowing it outside, it can also convert it to hot water and put it into this tank here. The evacuated tubes on the roof, which you heard about, that exchanges the heat with this tank over here. That was our first system for preheating the water. It's all about, let's get the water up to this temperature. If it's not enough, let's push it up further with the next system that it can do. So we've got a lot of recovery systems at different temperatures, so hence the whole control system of which one to choose first, which one do we start with to preheat and then run that water through the next system to try to get the water a little bit warmer without sacrificing energy. In case all else fails, we have an electric resistant heating element inside this tank. So it's just a basic unit that most people have in their home. We had it already in the tank when we bought it, so we figured why not hook it up just in case we want to heat it a little bit more if all the other systems weren't doing quite enough. This guy we don't expect to ever be running inside that tank. This tank is used as the final tank before the water goes out to your shower or to your sink. We're keeping that at 115 degrees all the time because of our hot water competition. We're required to fill up a bucket of water at 115 degrees in 10 minutes twice a day, and they don't tell us when. So we have to be prepared at all times. And they don't tell us when we're going to run the dishwasher or the washer-dryer unit either, so we've got to be ready for that. This is our energy recovery ventilator on our ceiling here. This is exchanging the bad air, the stale air inside of our home, with fresh air from the outside. What it's going to do is exchange heat as well as humidity and moisture in the air, so that when it leaves, say it's very cold outside, we're going to take that warm, moist air inside the home, and it's going to transfer the heat and the moisture into the incoming air and send it back into